Factoring quadratics, part 2. In this video, we're going to factor quadratics that have a leading coefficient other than 1. And we're going to try two methods, the AC method and the method of trial and error. A quadratic whose leading coefficient is not 1 comes from a multiplication like this, where the binomials don't start with a plain x. If I multiply this out, each of the terms 2x and positive 3 are multiplied by the second binomial 5x minus 7. Then we use the distributive property twice and then simplify. The two middle terms here will combine into 1. And so when I'm through multiplying, the resulting quadratic is 10x squared plus x minus 21. The middle term includes factors from each term of both binomials. So to undo it and find that middle term is a little complicated. But if you look up here at this level, it might remind you of factoring by grouping. And that's how we're going to undo 10x squared plus x minus 21. We're going to factor 10x squared plus x minus 21 by the AC method, which refers to the first coefficient and the last coefficient. Those are called A and C, and the middle coefficient is called B. The first step in the AC method is to multiply A times C and keep the signs. So A is 10 and C is negative 21, and when I multiply them I get negative 210. Well, our next step is to find factors of negative 210 that add up to 1. And since our product is negative and our factors will be one negative and one positive, it's quicker to look at the difference between the two factors. 210 is a big number, so we'd like to know how far down our list needs to go. And the square root of 210 is 14.5, so that means our list needs to go to 14. Numbers at the top of the chart, like 1 and 210, have large differences. The numbers at the bottom have small differences, so let's start at the bottom. And 14 goes into 210 15 times, and the difference is 1. So we've saved ourselves just a whole lot of work there. And so we have the factors of AC, 15 and 14, that add to B because the 14 is negative. Now here's a key step. These factors are going to split the middle term, B, into two terms. That is, I'm going to write 1x as equal to 15x minus 14x. 15 and 14 are not the constant terms of the binomials. 15 times 14 doesn't equal negative 21. Its purpose is to set us up so that we can factor by grouping. Our quadratic now has four terms, 10x squared plus 15x minus 14x minus 21, and so we can split it in half and factor by grouping. The order that you choose to put those two terms in won't make any difference in the long run. Well, let's cover up the second half and factor the first half. 10 and 15 have a common factor of 5, and x squared and x have a common factor of x. When I divide 10x squared by 5x, I have 2x, and 15x divided by 5x is positive 3. So I factored the first half. Now I factor the second half. The first term in the second half has a negative, so I'm going to factor a negative out of both terms. 14 and 21 have a greatest common factor of 7. And when I divide everything by negative 7, I get positive 2x and positive 3. Now it's time to look at the whole thing. There's a common factor of 2x plus 3, and that's multiplied by each of the terms 5x and negative 7. So I found the factorization 2x plus 3 times 5x minus 7, just what we started with when we multiplied to get that polynomial. The AC method is a lot of work. Sometimes it's the fastest way, but sometimes not. In this example, both A and C are prime numbers. And what that means when I'm factoring is that there aren't many possible combinations of binomials that will give me a 2 at the beginning and a 3 at the end. In fact, to get a 2 at the beginning, there's only one possibility, 2x times x. And to get a 3 at the end, there's only one possibility, 1 times 3. But the 1 might be with the 2 and the 3 with the x, or the 3 might be with the 2 and the 1 with the x. So in the method called trial and error, I multiply out these two combinations to see which one gives me the polynomial. To make it a little easier, I already know the first and last terms are correct, so I just need to check the middle term, which I think of as the rainbow term. 2x times 3 is 6x, and 1 times x is 1x, so the middle term of this combination is 7x. Hey! Look, that's my middle term. I don't need to check the second combination because I found it, and the factorization of a quadratic is unique. There's only one possible answer. But I'm going to check the second one just so you can see. The middle term here is 2x times 1 plus 3 times x, which would give me a middle term of 5x, not what we have. So 2x plus 1 times x plus 3 equals 2x squared plus 7x plus 3. Let's try factoring this polynomial, 4x squared plus 11x minus 3, by both methods. So first I'm going to start with the AC method. A is 4 and C is negative 3, so I want to multiply those together. 4 times negative 3 is negative 12. And I want to find all the factors of negative 12 that add up to be 11. It's negative, so I'm really looking at the difference, and the very first factor pair, 1 times 12, has a difference of 11. I use that to split the middle term, so 11x comes from a positive 12x and a negative 1x. Well, now I can factor by grouping. 4x squared plus 12x minus 1x minus 3 can be split in half. From 4 and 12 I can factor out 4, and from x squared and x I can factor out x. So 4x squared divided by 4x is a plain x, and 12x divided by 4x is a plus 3. Now I factor the second half. I factor out a negative, and really negative 1 is the only thing I can factor out, but I need to factor it out so that the signs will work out. So negative 1x divided by negative 1 is positive x, and negative 3 divided by negative 1 is a positive 3. So I factored using the AC method. If I'm using trial and error, I have a few more combinations in this instance because 4 is not prime. So it could come from 4x times x, but it could also come from 2x times 2x. So I have to try those possibilities as well. Negative 3 comes from either plus 1 times negative 3 or negative 1 times positive 3, or positive 3 times negative 1, or negative 3 times positive 1. So I would check 4 possibilities for the first 4x times x, and then the same 4 possibilities for the second combination of 2x times 2x. It seems like a lot of combinations to check, but remember, you only have to find the middle term. So suppose I'm checking negative 3 times 2 gives me negative 6, and 1 times 2 is plus 2. That's going to give me a negative 4. Turns out that the opposite sign combination just gives me the opposite sign middle term, so that cuts down on my number that I have to check. And when you notice that the big number is in the middle, it makes that combination that matches the 3 with the 4, which gives us the biggest possible product, and the 1 with the x, it gives that combination precedence in our mind. So if you're good at multiplying and quick and you can do things in your head, you might like this trial and error method. And if you'd like to be more step by step, the AC method is a great method.